Hey everybody! So in today's video, we're going to see how to use some new, or at least new-ish, functions in Microsoft Excel that give you the power to perform SQL-like data transformations without ever leaving the spreadsheet. Now don't worry if you've never used SQL, by the way. The scenario we'll work through will probably be pretty familiar to you if you've worked with data in really any capacity, whether in SQL, Excel, Python, etc. Now, speaking of our example scenario, what we'll be tackling today is a series of transformations that we'll apply to the data set you see here right in Microsoft Excel. So this real-world data set lists a series of data-adjacent jobs. Things like data engineer, data scientist, data analyst, etc., along with various data points about those jobs, like their salary, their required experience level, whether they're full or part-time, and so on. So as to those transformations we'll be applying, let's say, just for starters, that we're only interested in a subset of these rows of data where the values in column H, those being salary in US dollars, are greater than 250,000. In other words, we're only interested in investigating jobs with a minimum annual salary of 250,000. That sounds pretty ambitious, but hey, why not aim high? Now to accomplish this, we could just apply a filter to the dataset using standard Excel technology. So to do that, I would just select the entire dataset and then go to Data, Filter, and then roll back to the top. Then click the Filter button in my Salary in US Dollars column, hover over Number Filters, then greater than or equal to, and finally just type in my value, 250,000. Then hit OK. And now we've whittled this data set from 607 records down to 18. Much more manageable. But one problem with this approach, aside from all the manual clicking around, is that the rows we don't care about are still there behind the scenes, always ready to be a nuisance. You see, when you're working in a sheet where non-relevant rows are simply hidden, those hidden rows can inadvertently be included in calculations, summaries, or visualizations. And this, obviously, could lead to errors in your analysis. Now, one solution, which I've used many times, is to simply copy and paste the filtered dataset to a new sheet. So here I can just use the old Control-Shift right arrow, Control-Shift down arrow keyboard shortcut, and then copy this filtered dataset to a new worksheet. And the result here is that we only get the rows that we filtered for. The copied and pasted version of that filtered dataset no longer includes any hidden rows behind the scenes. But on the other hand, this solution introduces yet another manual step to our workflow, beyond just applying a filter to the dataset to begin with. Not good, but we'll roll with that for now. However, we now face another problem. We may have gotten rid of the rows we're not interested in, but there are lots of columns we're not interested in here as well. In fact, the only columns I am interested in here are job title, salary in US dollars, remote ratio, experience level, and employment type. Now again, there is a manual option here, just deleting those columns I don't care about. So of course, we all know how to do that. So I can select these first two columns and delete them, and then delete columns D and E, and then the employee residence column, and finally company location and company size. But even after doing this, I realized that the columns aren't even in the order that I want them. So now I need to move them around. So I want job title to be first, so I'll have to cut that and put it before experience level and employment type. Then I want salary in US dollars next. Then remote ratio. And finally, I'm okay with experience level and employment type being the fourth and fifth columns. So you'd think I'd be done at this point. But even now, I'm not quite done with all the mouse clicks just yet. You see, I'd actually like these results to be sorted as well, by job title. So of course, I can do that, albeit with another series of clicks. So I'll just select our much smaller data set, and then hit sort, and then sort by job title. And at long last, I've finally got this data set where I want it. But consider this. The next time the main data set gets updated with a few new records, guess what? I'm going to have to remember and re-execute all these steps all over again. Not my idea of fun. Now, if this data were in a relational database, handling all of these operations with SQL would be light work. Now, without the benefit of SQL, I could record some brittle VBA macro to do all these steps for me, and in the bad old days of Excel, that's exactly what I would have likely done. But in this glorious new era of Excel, there's now a much better way. Which, by the way, is what this video is all about. But before we get to that, I'll need to briefly introduce the relatively new Excel feature that will make all of this possible. Dynamic array functions. Don't worry, they're not as scary or complicated as they sound, at least for most use cases. So now, in a blank worksheet, let's see what these dynamic array functions are all about. So there is admittedly a lot of nuance to dynamic array functions in Excel, most of which I'm not going to get into here, but for most scenarios, just a solid understanding of the fundamentals is all you'll need to be dangerous. Now, the key thing to remember here is that what makes dynamic array functions in Excel different than standard Excel functions is that they can return a value to more than one cell. So if you think about how traditional Excel formulas work, you get exactly one return value for one formula. No more, no less. And if you do need to apply a formula across a range of cells, well, you need to copy or fill down that formula across all the cells where you need it. But with dynamic array functions, the old rules do not apply. So to see a simple example of this, let's take a look at a function called sequence. So the Excel sequence function generates a list or grid of sequential numbers. Basically, you just specify a number of rows and optionally a number of columns, and the sequence function will roll out a list of sequential numbers to the spreadsheet. Now, full disclosure, there are some additional optional arguments to the sequence function that can customize its behavior in ways that we won't see here. But the thing is, this video is not about the sequence function. We're just using this function as a mechanism to demonstrate some fundamental principles about dynamic array functions in general. So with that said, and without further ado, let's go ahead and use the sequence function to generate a list of numbers from 1 to 20, which is as simple as passing the number 20 to the first argument, the rows argument of the sequence function. So now hitting enter, you see that instead of returning a single value, the sequence function returned 20 values. We now have a list of numbers from 1 to 20 in cells A1 all the way down to A20. So this functionality, in which an Excel function can return not a single value, but an array of values across a range of cells, is called spilling. In other words, the output of the sequence function here spilled out of the cell where we entered the formula into a range of cells adjacent to that cell. Now, one interesting thing about this is that the actual formula only lives at the top left cell of the spilled range. So even though this formula's return value spilled out from cells A1 all the way down to A20, the formula itself only lives in cell A1 and can only be modified in cell A1. And if you click any of the other cells in this range, you'll see that the formula is grayed out, indicating that you cannot modify that formula while these other cells are selected. However, if we do modify our original formula in cell A1 to, say, return 10 rows instead of 20, you'll see that the return range dynamically changes in response. Now, lest you think that these dynamic array functions can only return arrays in one dimension, that being a column of cells, now let's experiment with adding the optional second argument to sequence. So here, I'll specify that in addition to 10 rows, we also want to return 5 columns. And now, because 10 rows by 5 columns yields 50 total cells, we get a sequence of numbers from 1 to 50, counting up from left to right across the 10 rows of the two-dimensional range of cells that our formula spills out to. Now, one thing you may have already wondered about, which is one of the major pitfalls of dynamic array functions, is what happens if an existing value in your spreadsheet gets in the way of this spilled range returned by a dynamic array function. Well, let's see. So down here in cell A11, just below our spilled range, I'll enter some text. So I'll just say, "Don't spill over me." So far, so good. But now let's see what happens if I modify our sequence function to return 11 rows instead of 10. Now we get a spill error. So it turns out that dynamic array functions are polite enough to not simply bulldoze over existing data in your spreadsheet. If there is a value in a cell that the array function would otherwise spill to, you'll get this spill error. So now if I delete this value down here, the output of our array function springs right back into place. So in general, this is just something you'll want to watch out for as you play around with dynamic array functions more and more. There's a reason they're called dynamic array functions. You never know how big the array they return is going to be. Okay, so I think that's entirely enough context and setup. Now it's time to get down to why we're here, which is solving our original filtering / cutting, reordering / sorting problem with dynamic array functions. But the first part of that solution actually has nothing to do with dynamic array functions. It's simply converting our range here to an Excel table. So first, I'll remove the filters from this data set. And then the steps to transform a range like this into a table, in case you're not familiar, are first to select the entire range and then just use the Control+T shortcut. And at this point, all we have to do is simply confirm the range of data that we want our table to encompass, which we've already selected, and also confirm that our table has headers, which, since we're converting this to a table, and tables definitely work best with column headers, it definitely should. So now clicking OK. Just like that, our data has been transformed to a table. Now, to make this table easier to work with, and specifically easier to reference in formulas, it's also really useful to give it a name, which we can do by simply overriding the default up here. And I'll just call it salaries. Now, while this step of converting your data to a table isn't necessary by any means to apply dynamic array functions to it, it does make working with them much easier. In fact, tables make working with this kind of structured data easier in almost every way. Just for example, tables in Excel automatically expand to include new data, which obviously makes it easier to manage growing data sets. They also help facilitate data analysis by enabling the use of structured references, which we'll see plenty of examples of here in a minute, which are more intuitive and maintain their accuracy as the scope of your source data changes. And that's aside from a whole host of other features that tables give you right out of the box, like automatic column headers and built-in filtering and sorting, just for starters. The bottom line is, if your data is tabular in nature, that is to say, organized into rows and columns, like our data set here, and like so many others, just convert it to a table. You won't regret it, I promise. But hey, this video isn't primarily about tables, so with all that said, let's tackle the first step in our data transformation process, which is filtering our data set to only include jobs that pay $250,000 or more. And this, of course, means we're finally going to get to play with a dynamic array function that does something more interesting than just return a list of numbers. So now, on a new worksheet, in cell A2, I'll use a dynamic array function called filter, imagine that, to return a filtered version of our data set as a dynamic array. So filter just takes two mandatory arguments. One is the array of data that you want to apply a filter to, which in our case is just the table we just created. And I can select that by just selecting the top left cell in our data, not including the column headers, and just simply doing Control-Shift-Right, Control-Shift-Down. And as you can see, Excel is smart enough to recognize that the range I just selected is actually our table. And of course, that means if I were to add new records to this table or delete records from the table, this reference to that table would be kept dynamically up to date. It also means, by the way, that to reference this table, we actually don't even have to go to the trouble of selecting cells. We can just type the table's name. Pretty cool. But now on to the second and much more interesting argument of the filter function. This is where we do the actual, filtering. So how this works is, you choose a single column from whatever array of cells that you want to apply a filter to, with that column being the specific one that's the basis of your filtering logic. Now in our case, that means the salary in US dollars column. So now all I have to do is select the entirety of the data in that column. So I'll just do Control-Shift-Down. So now, speaking of those structured references, instead of seeing something like H2 through H608, we just see the name of our table followed by the name of the column we selected in brackets. So once again, our formula doesn't have to worry about which cell our data starts in and which cell our data ends in. We just reference the name of the column in the table. But of course, simply referencing this column is not enough. We actually have to apply a criteria to it. And that works just like it would in any other old Excel function. We just type greater than or equal to 250,000. It's just that simple. Okay, so with that said, let's close that parenthesis and then hit enter. And look at that. There are those same 18 jobs with salaries greater than or equal to 250,000, all returned by a single simple formula. That wasn't so hard, right? And the great news is the next two steps are even easier. Now, one thing that might be troubling you here is the conspicuous absence of column headers. But don't worry, we're going to tackle that right now in step 2. But first, part 1 of step 2 is going to be to select just the columns from this filtered data set that we're interested in and in the order in which we want to see them. And as you might have guessed, a dynamic array function can help us here too. Specifically, the CHOOSECOLS function, which, as the name suggests, allows you to specify which columns you want to choose from a data set, but also allows you to specify the order in which you choose those columns. So to do that, I'll click up here in the top left corner of our range where we can actually modify our formula, and then I'll wrap our filter function here inside of a CHOOSECOLS function, which basically means the array that is returned by our filter function will be passed into the CHOOSECOLS function as its target array. So after the equal sign, but before filter, I'll type CHOOSECOLS, or rather, let Excel give me an assist in doing so. And as you see, the first argument is an array of cells, which filter has already taken care of for us by returning us that filtered array of cells from our original data set. So now the second argument is simply the position of the first column that we want to actually select in the array of data that we passed into the first argument. So the first column we want to appear in our output is the job title column, which just happens to be the 5th column in our data set. So we'll simply type the number 5. And at this point, you might have guessed how the rest of this is going to go. The next argument is just the position of the next column we want to select, and that will be the salary in US dollars column, which is at position 8. Then we want the remote column, which is at position 10. Then we want the experience column at position 3. And finally, the job type column at position 4. So now closing our parenthesis and hitting enter, we get just those columns we care about and in the order that we wanted them. So things are coming along nicely, but we still haven't solved the column header issue. Well, CHOOSECOLS can help us here too. I mean, given that the rest of our solution is dynamic and formula driven, we don't want to be copying and pasting or typing in column headers now, do we? So to fetch in those column headers dynamically, we can again use CHOOSECOLS with the exact same positions that we supplied as the last 5 arguments, with the only difference being the array that we pass to the first argument of CHOOSECOLS. In this case, that array will just be the column headers from our source data set. So to make life easier on ourselves, I'll actually just copy this whole formula and then paste the text of that formula here in cell A1 where our column headers will begin. And then I'll wipe out our filter function and replace that with a reference to the header row of our source data set. So I'll roll over to the first column and then Control-Shift-Right. And sure enough, we see a structured reference to just the headers of our table as well. So now hitting enter and then fitting column widths so we can actually see our work. There we have it. Just the rows and just the columns that we're interested in, all returned by just 2 formulas. Okay, so we're almost there. All that's left is to sort our data set here by job title. So now let's wrap our formula here inside of one more dynamic array function to get this thing over the finish line. And that function, in case you haven't been able to guess the name already, is the sort function. Now, like the other 2 functions we've just worked with, the sort function takes an array of cells as its first argument. And just like we fed the output of the filter function into that array argument of the CHOOSECOLS function, now we're going to take the array of cells that CHOOSECOLS returned and feed that to the sort function. In simpler terms, we're really just sorting the data that we see here which of course was the output of the CHOOSECOLS function. So now that we've specified our array, all that's left is to specify the column that we want to sort by. And we do that based on its position. Just like when we specified the positions of the columns we were interested in with the CHOOSECOLS function. Now we want to sort by job title. And in our original data set, the job title column was at position 5. But remember, the array that we're feeding the sort function is a modified array that has had rows removed by the filter function, and more crucially, has had columns removed by the CHOOSECOLS function. So in this modified array, the job title column is actually at position 1. So I'll use 1 as the second argument here, and that's all we need to sort this little data set by job title. So now hitting enter. Sure enough, applied data scientist and applied machine learning specialist bubble up to the top. Now, of course, those A's being first means that the data is sorted in ascending order by default. But if you want to sort in descending order, you can add an optional third argument to the sort function in which you specify -1 for sort order. That tells the sort function you want to sort in descending order. Optionally, you could always specify 1 for ascending order, but it's not really necessary since that's the default. So now hitting enter again, we see that applied data scientist and applied machine learning specialist have now dropped all the way to the bottom of our data set. So it looks like things are being sorted in descending order. And with that, and congratulations for making it this far, by the way, our little formula-driven solution is complete. With just 3 dynamic array functions and a single formula, we were able to execute a data transformation operation that would have taken several lines of SQL code, just for example. Now, speaking of those 3 dynamic array functions, I do want to mention that while you can technically perform these transformation operations in any order that you want, I personally recommend the exact order we saw here. First, apply the filter function to filter for only the rows of data you're interested in. Then, use the CHOOSECOLS function to select the columns that you're interested in and to specify the order in which they appear. Then finally, use the sort function to sort your filtered data set in any way that you see fit. Now, incidentally, this happens to be the exact order in which the same operations are carried out by a SQL query. At the risk of overusing the comparison, this truly is like fetching data from a database table using SQL, but without ever having to leave Excel, and so much easier to boot. Now, as the last piece to this demo, I just want to show off how flexible and dynamic our solution here is. So going back to our source data set, let's say we want to add a new job to this data set with a title that has not been used in this job title column up to this point. So I'll use Control down arrow to get to the bottom of the data set. And then because we're working with a table, all I have to do is enter a value in this first blank row beneath the table, and this entire row will then be automatically incorporated into the table. Now, to prove that to you, let me just type our new job title, which will be Data Guru. Then while I'm at it, and to ensure that this job meets our criteria, I'll give it a salary of, say, $1 million. So now hitting enter, we officially have a new job that is officially part of this table. So now let's see if our dynamic array formula was able to pick up on this new record that meets our criteria. And sure enough, it was. Not only did a new row for our Data Guru job magically appear in our dynamic array formula output, it also appeared in the perfect sort order relative to the other jobs in the list. And this just underlines how flexible this solution is. Whether we add new records to our source data table or delete records from that table, we won't have to worry about modifying our formula here. Either way, it just works. All right, folks, that's it for this one. Hope you enjoyed, and make sure to keep an eye out for new content on my channel. Subscribing really helps with that, by the way. Just saying. See you next time.